Hello everybody, welcome to A to Z Learning Hub. Today is our fourth class of unit and dimension. And we have already discussed about two applications. Today is our third application to convert one system of a unit to other system. We know there are different types of systems of unit like CGA system, MK system, FPA system, SI system like this. Now, how we convert one system of unit to other system? That means, suppose we are given MKs, we convert them into CGS and vice versa. Let us take a hypothetical quantity X. Let its dimensional formula is m to the power a, l to the power b, t to the power c. Or we can say the dimension of the physical quantity is a, b, c. Or dimensions of physical quantity is a, b, c. You see, we convert one system of a unit to other system. Let us take system 1 and here it is the system 2. In system 1, let its magnitude is n1. In system 2, its magnitude is equal to n2. You see, let its unit is u1 and let its unit is in system 2 u2. So, in system 1, so the physical quantity is written as n1 u1 and here it is n2 u2. But we know, n1 u1 is equal to n2 u2. Again, in system 1, let mass is equal to m1, length is equal to L1, time is equal to T1. In system 2, mass is equal to M2, length is equal to L2 and time is equal to T2. So, the physical quantity are in system 1 are written as N1 into M1 to the power A, L1 2 to the power B, T1 to the power C. And in system 2, it is written as N2 into M2 to the power A, L2 to the power B, T2 to the power C. You see, N1 gives the magnitude and this dimension gives its unit. Similarly, in system 2, N2 gives the magnitude and this dimensional formula gives the unit in system 2. So, N1 into M1 to the power A, L1 to the power B, T1 to the power C is equal to N2 into M to the power A, L2 to the power B, T2 to the power C. So, N2 is equal to N1 into M1 to the power A, L1 to the power B, T1 to the power C by M2 to the power A, L2 to the power B, T2 to the power C. Or we can write N2 is equal to N1 into M1 by M2 whole 2 to the power A, L1 by L2 to the power B, T1 by T2 whole 2 to the power C. This is the formula. Applying this formula, we convert one system of a unit to other system of a unit. So, I am telling you again, let us take a physical quantity, hypothetical physical quantity x. Let its dimensional formula is m to the power a, l to the power b, t to the power c. So, we can say its dimension is a, b and c respectively. Now, we take two systems. In system 1, its magnitude is n1. In system 2, its magnitude is n2. And in system 1, its unit is equal to u1. In system 2, its unit is equal to u2. And in system 1, we write its mass is equal to m1 l1 t1, and system 2 mass, length and time are m2 l2 t2. So, we can write in system 1 it is written as n1 u1 that is equal to n2 u2, or we can write n1 into m1 to the power a, l1 to the power b, t1 to the power c is equal to n2 into m to the power a, l2 to the power b, t to the power c. You remember, this part gives the magnitude and this part gives the unit, or a dimension gives the unit. This is your n2 is equal to n2 into this. So, n2 is equal to n1 m1 l to the power a, l1 to the power b, t1 to the power c by m2 to the power a, l2 to the power b, t2 to the power c, or n2 is equal to n1 m1 by m2 whole to the power a, l1 by l2 whole to the power b, t1 by t2 whole to the power c. This is the formula. Now, I am giving you some conversion factors. You know, 1 kg is equal to 1000 gram, that is equal to 10 to the power 3 gram, or 1 gram is equal to 10 to the power minus 3 kg. Similarly, 1 meter is equal to 100 centimeter, that is equal to 10 to the power 2 centimeter, or 1 centimeter is equal to 10 to the power minus 2 meter. Again, you know, 1 minute is equal to 60 seconds, or 1 second is equal to 1 by 60 minutes, like this. So, using this, we convert one system of a unit to other system of a unit by using that equation. Question number 1, convert the force of 300 Newton, that is SI, to CGS system. Here, the physical quantity is force. First you write force. Its dimensions are 1, 1 minus 2, or its dimensional formula is m1 L1 t to the power minus 2. You see, here it is your system 1 and here it is your system 2. Given, which is given, that is the SI, and we have to convert into CGS. You see, in system 1, its magnitude N1 is equal to 300, N2 we have to find. Since it is SY, let M1 is equal to, you always take 1 kg, you always, L1 is equal to 1 meter and T1 is equal to 1 second. And here you take M2 is equal to 1 gram, L2 is equal to 1 centimeter and T2 is equal to 1 second. So you apply the formula, you write N2 is equal to N1, M1 by M2 whole to the power A, L1 by L2 whole to the power B, T1 by T2 whole to the power C. You see, that is equal to N1. N1 means 300. That is your M1. M1 is your 1 kg by 1 gram to the power A. A means 1. L1, 1 meter by 1 centimeter to the power 1. 1 second by 1 second to the power minus 2. You write this. You see, important thing. Here you see, you don't change the denominator part. Only you change numerator part. That is equal to 300 into 1 kg is equal to how many gram? 10 to the power 3 gram divided by 1 gram. Don't change 1 gram to the power 1 into 10 to the power 2 meter, 10 to the power 2 centimeter, because you know 1 meter is equal to 10 to the power 2 centimeter by 1 centimeter to the power 1 second by 1 second, that is to the power minus 2. So we can write 300, your gram cancel, 10 to the power 3 1 by 10 to the power 3 to the power 1, that is equal to 10 to the power 3. Here you also centimeter cancel, that is your 10 to the power 2 to the power 1, 10 to the power 2. Here second cancel, 1 to the power minus 1, that is equal to 1. That is equal to, write 300 into 10 to the power 5 CGS, or we can write 3 into 10 to the power 2, 10 to the power 5 CGS means you can write it dyne. That is equal to 3 into 10 to the power 7 dyne. So 300 Newton is equal to 3 into 10 to the power 7 dyne. Question number 2. Convert the velocity of 50 centimeter per second to SI. You see, how can you do it? Here the physical quantity is velocity. You remember, its dimensional formula is equal to m0 L1 t to the power minus 1. So, A, B, C are 0, 1, minus 1. Here it is given centimeter per second. Here this is your system 1, it is your CGS, and here it is your system 2, that is your SI. You remember, here N1 is equal to 50, you have to find N2. Since it is CGS, M1 is equal to 1 gram, you always take M2 L1 is equal to 1 centimeter, T1 is equal to 1 second. Next, M2 is equal to 1 kg, as it is converted to SI. L2 is equal to 1 meter and T2 is equal to 1 second. So, the physical quantity in system 1, N1, E1, that is your 50, your M1 to the power what? 0, L1 to the power 1, T1 to the power minus 1, and here N2 U2, that is your, we have to find N2 into M2 to the power 0, L2 to the power 1, T2 to the power minus 1. Or you apply direct formula. Here N2 is equal to N1 M1 by M2 whole to the power 0, L1 by L2 whole to the power 1, T1 by T2 whole to the power minus 1. Here you see it is your 50 and here M1. M1 is equal to 1 gram by 1 kg. You remember, this is your 1 centimeter by 1 meter. This is your 1 second by 1 second to the power minus 1. You see, this is your 50. I have already told you, don't change denominator, we change numerator. That is your 10 to the power minus 3 kg, you know 1 gram by 1 kg to the power 0, 10 to the power minus 2 meter by 1 meter to the power 1 into 1 second by 1 second to the power minus 1. So you write 50 something to the power 0 is equal to 1. Here meter cancel into 10 to the power minus 2 to the power 1 into here 1 to the power minus 1. That is equal to 50 into 10 to the power minus 2 SI, or we can write 50 into 10 to the power minus 2 meter per second, or we can write 5 into 10 to the power minus 2 meter per second, that is 5 into 10 to the power minus 1 meter per second. So, 50 centimeter per second is equal to 5 into 10 to the power minus 1 meter per second. You see, your question is, find the value of 100 joule to a system taking 20 centimeter, 250 gram and a half minute as a fundamental unit. You see, here solution. Physical quantity is work, because its unit is joule. Its dimensional formula is equal to m1 L square t to the power minus 2. So A, B, C are 1, 2, minus 2. You see, in system 1, here N1 is equal to 100 joule. Here in system 2, we find N2. In system 1, M1 is equal to, as it is given joule, that is your 1 kg. L1 is your 1 meter. T1 is your 1 second. Here in system 2, you see, M2 is equal to, you don't write 1 gram, you write 250 gram. L2 is equal to 20 centimeter, don't write 1 centimeter. And T2 is equal to half minute, that is equal to what? 30 seconds. So, applying formula, you write N2 is equal to N1. N1 means 100 into M1 by M2. M1 means 1 kg by M2. 250 gram whole to the power 1. Your L1 is 1 meter by 20 centimeter whole to the power 2. Your 1 second by 30 second whole to the power what? Minus 2. That is your 100. This is your 1000 gram by 250 gram to the power 1 into 100 centimeter by 20 centimeter to the power 2. Your 1 second by 30 second to the power minus 2. So you can write 100 into 1000 by 250, that is your 4, into this is your 5, this is 5 to the power 2. This is your 5 to the power 2, that is your what? 25 into, this is your 1 by 30 to the power what? Minus 2. So we can write 100 into 100 into 30 to the power minus 1 whole to the power minus 2, that is your 100. That means this is your 10 to the power 2 into 10 to the power 2. Your 30 to the power 2 means what? 900. That is your 10 to the power 2 into 10 to the power 2. 9 into 10 to the power 2. That is your 9 into 10 to the power 2. 2 plus 2 plus 2. That is your 9 into 10 to the power 6. The given system. You see again, this is your 100, 1 kg by 250 gram, 1 meter by 20 centimeter, 1 second by 30 second, because half minute means 30 second, 100, this is into 1000 gram by 250 gram, because you have taken it as a fundamental unit. 100 centimeter by 20 centimeter, 1 second by 30 second, your 100 into, this is your 4, this is your 5 to the power 25, this is your 1 by 30 to the power, second cancel to the power minus 2, 100 into 100 into 30 to the power minus 1 into minus 2, this is your 10 to the power 2 into 10 to the power 2 into 900, 10 to the power 2 into 10 to the power 2, this is your 9 into 10 to the power 2, that is equal to 9 into 10 to the power 6 in the given system. some miscellaneous problems. P plus A by V square into V minus B is equal to RT. Here P is the pressure, V is the volume, R is a gas constant, T is absolute temperature. Find the dimensional formula of A, B, AB and A by B. Here A and B are constants. You see, how can you do it? You see, P plus A by V square. Since A by V square is added to P, so we can say A by V square is pressure. Anything is added to pressure or anything is subtracted from pressure, that physical quantity must be pressure. A by V square is equal to pressure. So A is equal to pressure into V square means volume square. Or A is equal to, you know what is the dimensional formula of pressure? M1 L to the power minus 1 T to the power minus 2, you know it, into volume dimension LQ to the power 2. So A is equal to M1 L to the power minus 1 T to the power minus 2 into L to the power 6, or we can write M1 L to the power 5 T to the power minus 2. This is the dimensional formula of A. Again you see V minus B. Since B is subtracted volume from volume, so B is equal to volume. So dimensional formula of B is equal to what? M0 LQ T0. Because it is subtracted from volume, we find the dimensional formula of A, and this is the dimensional formula of B. Third question, dimensional formula of AB, that is your what? M1 L to the power 5 T to the power minus 2 into LQ, that is equal to M1 L to the power 8 T to the power minus 2. Again, dimensional formula of A by B, that is equal to what? M1 L to the power 5 T to the power minus 2 divided by what? Volume. What is the dimension of a volume? Dimension of B, that is your LQ, that is equal to what? M1 L square T to the power minus 2. This is the dimensional formula of A by B. This is the dimensional formula of AB, this is the dimensional formula of A, and this is the dimensional formula of B. V is equal to A plus BT plus CT square plus D by E plus T, where V is velocity and T is time. Find the dimensions of A, B, C, D and E. You see, velocity is equal to this plus this plus this plus this. So each term must be velocity. So A is equal to solution. A is equal to velocity and its dimensional formula is M0 L1 T to the power minus 1. BT is equal to also velocity, or B is equal to velocity by time, that is M0 L1 T to the power minus 1 by T. That is your what? M0 L1 T to the power minus 2. CT square is also velocity, or C is equal to velocity by T square, that is your M0 L1 T to the power minus 1 by T square, that is your M0 L1 T to the power minus 3. This is the dimension of C, dimensional formula of C. Again you see, your E plus T, since time is E is added with time, so we can say dimensional formula of E is equal to m0 l0 t1 because E is added with the time, so the E must be time. So its dimensional formula is m0 l1 t1. Again you see d by E plus t is equal to velocity also, or d by this is the time plus time, its dimensional formula is time is velocity, that is your m0 l1 t to the power minus 1, or d is equal to what? m0 l1 t to the power minus 1 into t, or d is equal to m0 l1 t0. So d is a length. So this is the dimensional formula of A, this is B, this is C, this is E, and this is T. Another problem, P is equal to A minus T square by Bx. You see, since T square is subtracted from A, that means time square is subtracted from A, so A must be A is equal to time square. So dimensional formula of A is equal to m0 l0 t to the power 2. You remember? Here t square is subtracted from A. Since t square is subtracted from A, that means time square. So we can say A must be time square. Otherwise, we cannot subtract t square from A. So this is the dimensional formula. Again, P is equal to what? This is your what? T square. Its dimensional formula is t square by B into your what? This is your L means displacement, this is your length. So B into L T square by P. P means pressure. Or BL is equal to T square. What is the dimensional formula of pressure? We can write M1 L to the power minus 1 T to the power minus 2. So B is equal to, you can write T square divided by M1 L to the power minus 1 T to the power minus 2 into L. You take L to denominator side. So B is equal to T square divided by M1, this is your L0 T to the power minus 2, or we can write B is equal to M to the power minus 1 L0, L is nothing, L0 is equal to 1 T to the power 4. This is the dimensional formula for A, that is M0 L0 T to the power 2, and this is the dimensional formula of B. Again I am telling you about B. You see, since T square is subtracted from A must be T square, and you see P is equal to your T square minus T square is equal to T square, that is B into L, or BL is equal to T square by pressure, or BL is equal to T square by M1 L to the power minus 1 T to the power minus 2. You know this is the dimensional formula of pressure. Or B is equal to T square by M1 L to the power minus 1 T to the power minus 2 into L, that is T square by M1, this is your L to the power minus 1 L to the power 1, that is L to the power 0 T to the power minus 2, that is B is equal to, you take to upper side M to the power minus 1 L0 T to the power 4. Here the dimensions of A and B you determine. Again you see, if it is given the dimensional formula of AB, you can write for dimensional formula of A is T square, your M to the power minus 1 L to the power 0 T to the power 4, that is your M to the power minus 1 L to the power 0 T to the power 6, and the dimensional formula of A by B, this is your A means T square divided by m to the power minus 1, L to the power 0, T to the power 6. We can write m to the power 1, L to the power 0, T to the power minus 4. This is the dimensional formula for A by B. These are some problems. Now, I am going to tell you limitations of dimensional analysis. Limitations of dimensional analysis. You see, there are so many limitations. First, you see, this method gives no information. This method gives no information about proportionality, dimensionless constant. You see, when we derive the relation, we suppose in case of a centripetal force is equal to K mv square by r. This method, this system is silent about K. It could not say what is the value of K. That means you have to write K in this expression. This is the first limitation. This method gives no information about proportionality, dimensionless constant. Second one is, if a quantity depends upon more than 3 quantities, we cannot derive relation by this method. Suppose force depends upon mass, velocity and radius, we can derive the relation. Suppose the physical quantity depends upon 2 factors, we can derive the relation. But if a physical quantity depends upon, suppose P, Q, R, S, more than 3 factors, we cannot use this method to find the relation. Third limitation, if a relation contains trigonometric expression or a logarithmic expression or exponential function, power function. Exponential means power function, we cannot derive the relation by this method. Fourth one is, this method cannot derive exact relation. In this method, we cannot derive exact relation because we cannot know what is the value of a dimensional proportionality, dimensional constant. We find only dimensional relation. Dimensional relation. This is the fourth property, fourth limitation. And your fifth one is, if dimensions are given, we cannot find the physical quantity. In some cases. Suppose our dimensional formula is m1 L square T to the power minus 2. I will ask you, what is the physical quantity? Someone will say it is work. Someone will say it is torque. So this dimensional formula stands for different physical quantities. So if the dimensions are given, we cannot find the physical quantity in some cases, actual physical quantity in some cases. Another limitation, This analysis could not say which physical quantity is scalar and which is vector. You see, there are some physical quantity which have only magnitude. Suppose I will say I am going towards, I am going 5 kilometer. This is scalar. Suppose I will say I am going 5 kilometer towards east. This is vector. So here it has only magnitude, scalar has only magnitude, but vector has both magnitude and a direction. So this system could not say which is a scalar quantity and which is a vector quantity. These are the limitations of a dimensional analysis. So for today, if you like my teaching, please subscribe my channel, share my channel, so that I will be motivated to give you better and better video. Please subscribe my channel. For today, thank you everybody.